welcome everyone. Bonjour tout le monde. J'espère que vous êtes bien réveillés et que vous avez assez hâte d'entendre ce que nos panélistes ont à dire. I hope that you've been enjoying the conference so far. And today's panel is going to be, I think, extremely interesting and exciting. It's certainly on a very important and I would say timely topic, which is to essentially adapt and mitigate to climate change, and specifically, how can we get the carbon out of our environment? And you've probably heard a lot about carbon capture. It can happen in so many different places, believe it or not, including in the oceans. So I think this is going to be super exciting to see how our oceans, which we know already participate in modulating climate, positively and negatively, depending where you are, how we can perhaps get them to help us in our objective of maintaining the increase in temperature to 1.5, which I don't want to depress anybody, is sounding and seeming increasingly difficult these days. So we have, I think, all been affected one way or the other, or we have relatives and friends who have been affected this year by the consequences of climate change, whether it's the heat waves, whether it's floods, whether it's wildfires, and you name it. In fact, my heart, and I'm sure our collective thoughts, are with our friends out west that are experiencing, new and incredibly difficult phenomena. So you probably also have heard that the European Copernicus, I think it's the right call, they've declared that 2024 already is the warmest year on record. And we don't have to go very far to see what was the previous record. It was actually 2023. So, the hotter and hotter, faster and faster, we've got to do something about it. And I think we all agree that technologies, science, innovative solutions are gonna have to be part of the equation in all combinations and forms. And for this, we need researchers, innovators. We need governments actually to provide the framework, whether it's policy, whether it's regulatory, that will enable the safe actually adoption of such solutions. We need the private sector to engage. And I just want to remind everyone that the most successful multilateral agreement is the Montreal Protocol that actually has been people said it's impossible, but actually we managed to keep using cooling devices and refrigerators, but just substitute the gases in there and the technologies and so on. And that was successful because it involved close working relationship between governments, scientists, technologists, and the private sector. And of course, I don't want to forget civil society, philanthropic groups, people advocating on behalf of everyone and facilitating connectivities and advising in non-partisan manners and objective manners. So we have all these sectors here today. So it's going to be wonderful. We're going to be able, in principle, to go end to end in seeing what is it that it takes to have these solutions, how close are we, and of course, answer questions that you may have. So with me, very distinguished experts. I'll just very quickly present them maybe very, very quickly. You know, the bios are in the binder. So we have Kate Moran from the University of Victoria, who's the president and CEO of Ocean Networks Canada. We were supposed to have Nicole. We have a new Nicole. Unfortunately, Nicole is under the weather today and very regretfully is unable to join us. But we have her colleague from Environment and Climate Change Canada, David Telfer. And I have Naeem here with me, the Executive Director from Carbon Removal Canada. And last but not least, I have Mike Callan, the co-founder and CEO of Planetary Technologies. So there you have it. We're all ready. Kate, please get us started.
Thank you. I'll use the podium. Yes, thank you all. I just want to first start with that we acknowledge that we're on the location of this meeting is on the traditional unceded territories of the Algonquin Nation. We also, from Ocean Networks Canada, acknowledge the many Indigenous communities with whom we have the honor to collaborate with for monitoring and data management along all 3 coasts of Canada. This is a deep dive into ocean climate solutions. It's something that is dear to my heart, and I hope I can share with you the knowledge that we have so far and what we can do to go forward. In this presentation, I'll shamelessly first talk about Ocean Networks Canada, then give a high-level view of the ocean and carbon dioxide, and then talk about the 2 types of technology we're showcasing here today, marine carbon dioxide removal, and then a project called Solid Carbon, which I'll explain is part of the ocean seafloor. A little bit about Ocean Networks Canada. This is an animation of the deep ocean circulation on the planet. It's called the Global Conveyor Belt. It took 4 decades of ocean research to actually understand this system because satellite data doesn't penetrate the top of the ocean, and this is all below the sea surface. So the motivation for Ocean Networks Canada was to provide a monitoring system to understand the sea beneath the surface, including everything from the ocean water, life in the ocean, the interaction with the continents. And of course, because we started on the west coast of Canada, as you see in this bottom panel, understand the rich dynamics of the seafloor of the ocean, which is very dynamic compared to many places on the planet. And that's to understand everything from tsunamis and earthquakes and hot vents and cold vents, which I won't talk about today except for one kind of venting. So remember the bottom panel when I come back later in this presentation. But that monitoring then led Mavericks from the University of Victoria to develop new technology using telecommunication cables, which you see as white lines on this map, to connect sensor systems beneath the seafloor, on the seafloor, in the water column, and now on land, and then provide that data in real time 24/7. The orange squares are nodes that provide that power and internet connectivity to these rich sensor systems. We've been operating now for 22 years, providing real-time data about all aspects of the ocean that I just described. And now, because of the fact that we have been effectively developing data and data products in the West Coast, we have been populating observations, mainly in partnership with Indigenous communities, on all 3 coasts of Canada. And so I welcome you to visit Oceans 3.0, where all the data are open to you to view at your leisure. We are one of Canada's major science initiatives. We were established as a nonprofit society by the University of Victoria in 2007. We have funding from the Canada Foundation for Innovation, and we operate over 12,000 sensors in real time. We're now growing our database with a rich amount of data. And of course, we have over 37,000 users of our infrastructure. So we are one of the largest major science initiatives and now a major research facility for Canada. We have 3 goals. I'm not going to talk about the first 2. Of course, you just saw we advance ocean observing. We also develop data and data products, and we will be developing data products in this space. But goal number 3 is what we're focused on here today, where we're enabling research to advance ocean climate solutions in the mitigation space, also in the resilience space, which I won't mention today. The ocean and the carbon system is what I first like to show you this is an image that you don't usually see of planet Earth. This is an image of the Pacific Ocean. And this is why our planet should be called the ocean rather than the Earth. This is just to give you where we are. This is an arrow that shows Victoria on the map. But we are an ocean planet, and it's 70% of our planet. And in fact, the ocean has the most amount of carbon of any part of our planet. As you can see here, 37,000 gigatons sit in the ocean space as compared to hundreds in the atmosphere. And as many of you have heard over and over again, the ocean has been our friend. It has been absorbing over 30% of the CO2 emission, of the greenhouse gas emissions from man, and it has absorbed 90% of the heat. If we didn't have the oceans on the planet would already be cooked. So remind yourselves always that the ocean has been our friend in this space, and we want to actually use it sustainably to help us going further. That was all supposed to, of the water column. This is that panel I showed you earlier. This is a spreading center at the Juan de Fuca Ridge where new ocean crust is formed. And this is a location where there's ocean basalt, a type of rock that's very unique, I'll talk about again. But what you see at the spreading center are hot vents that create new ocean crust, or hot vents that sit in a location that create new ocean crust, which is basalt. And as that moves away from the spreading center, it forms this system of ocean basalt that sits below ocean sediment. And I'll be talking about this because we now know, because of research in Iceland, that when you inject CO2 in basalt, it turns into rock in years. 2 years in Iceland and probably the same amount of time in offshore Canada. So in the water column space, in terms of ocean-based carbon dioxide removal, it's now by the scientific community called marine carbon dioxide removal, or MCDR. And I had the honor of being on a US National Academy study that kicked off developing the research needs for a wide range of carbon dioxide removal solutions to advance them and assess them to see what can be utilized, weighing the risks and the benefits of pulling CO2 out of the atmosphere. Ocean nutrient fertilization, ecosystem recovery, seaweed cultivation and biomass sinking, artificial upwelling and downwelling. And what you're going to hear about today as a specific example is ocean alkalinity enhancement. And of course, we can use the chemical processes also to remove CO2 from the surface ocean. So this report is available online from the US National Academies, so feel free to download it for further reading. In terms of Ocean Networks Canada in this space, we obviously monitor ocean change. What you see up in the left block is that we have been monitoring ocean change where there are things like the big blob and warming in the Pacific Ocean. And then we can actually understand the impact on life in the ocean. So that's an important part of understanding ocean change. But we also provide data openly and transparently to develop what we call ocean intelligence. What does that data mean in terms of how it affects the planet? And then our platforms, in terms of our physical and digital platforms, provide a real-time ocean environment to be a test bed for marine carbon dioxide removal and for a project called Solid Carbon, which is injecting CO2 into ocean basalt. These are the partners that we have in marine carbon dioxide removal. Planetary, you'll hear about that further. And so we will continue to use our platform to help startup companies and researchers advance these marine carbon dioxide removal solutions. And I need to pause to say Ocean Networks Canada is really agnostic to these. We're not advocating one or the other. Our role is to provide the research platform to assess them and help these companies develop the technology and then openly provide the data so it can be assessed for its use to weigh the benefits and the risks. In terms of solid carbon, I'm going to now go to the seafloor. The durability of this has been proven in Iceland. Iceland is a piece of ocean basalt that's above the water, above the sea level. And most of the basalt is in the ocean. And Canada has this unique location, unlike on Iceland, where it's all on land, off of our coast on the Neptune Observatory, where it's been studied by the Geological Survey of Canada and geophysicists and geologists from Canada and internationally, that we've studied this location called Cascadia Basin for 4 decades and know it better than any other place on the planet for ocean basalt. And that particular basin, based on our research and feasibility studies, has the capacity to store 750 gigatons of CO2. So for those of you who don't know the CO2 numbers, 750 gigatons is 15 years of global emissions. It also can, if we prove this in Canada, this technology and the way we use it can be an industry that goes global and can be a big part of the solution. If you look at the typical diagram that was initially started by the UN Environment Program, we need to have negative emissions, as was mentioned earlier by our chief scientist, that we have to remove CO2 from the atmosphere to keep the planet habitable for humans and biodiversity. Solid carbon and MCDR has the potential to provide a rich amount of that removal of CO2 from the atmosphere. In the Solid Carbon Project at Ocean Networks Canada, we are not focused on the direct air capture needed to pull CO2 out of the atmosphere. There's great investment happening globally, including in the US, which then is investing over $1 billion in that. That is moving along, that technology is moving along. What we're trying to prove is that we want to demonstrate what was happening in Iceland by injecting in the Cascadia Basin CO2 beneath the seafloor. And so our next step is to do a robotic-based demonstration. We have incredible robotic development as we have evolved Ocean Networks Canada using robots for everything that we do in the deep sea. We're going to extend that to actually hopefully doing a demonstration using robotic systems in the near future. We also have a great number of partners in solid carbon. So as our chief scientist said, it takes a village across all these sectors to make all of these happen. And so my message and our message from the panel is that this is a potential for Canada to be a global leader in this space. We are an ocean nation, the longest coastline in the world, and we have already examples of this on the East Coast that you'll hear about soon. And of course, now we have this major research facility that is ready to advance research in these areas. So over to the policy experts. Thank you very much.
Thank you, Kate. This is a great way to start because, policy without science and technology is actually not very helpful, right? It's not going anywhere. So perhaps, David, you can enlighten us now about, what does it take and how far are we from actually, delving into all these policy solutions?
Okay, thanks. And apologies, I'm going to have to use some notes here because being a last-minute stand-in, and Nicole does send her apologies. I was speaking to her at about 4:15 last evening in the office, and it seems she came down with something last evening. So, all right. So yeah, I'm going to try to set the stage for sort of the policy side of this issue. I'll be talking about a number of things, including ECCC's mandate, the government's climate change commitments, just a bit to set the scene, and discussion about both international and domestic work in this area. So the Government of Canada is committed to achieving net zero emissions by the year 2050. This commitment is enshrined in our Net Zero Emissions Accountability Act, along with Canada's commitments towards its 2030 nationally determined contributions to reduce emissions by 40 to 45% by 2025 levels. The government, along with other governments, recognizes that the best way to tackle climate change is to stop new emissions from entering the atmosphere, and this remains the top priority of Canada's climate change plan. While it's widely recognized that reducing emissions is the primary approach, it's becoming increasingly apparent that the carbon dioxide removal is essential to achieve net zero, both because there will be residual emissions as a result of hard-to-abate industries, but also in order to address the historical emissions that have been put into the atmosphere that must be dealt with. And I think that's one of the areas where these technologies that we're looking at have the biggest role to play. So the government is monitoring the development of CDR, and my group specifically marine CDR, also solar radiation management, and there are some marine solar radiation management or modification techniques that we are looking at as well. And the interest is increasing globally. It's a complex topic that is gathering more attention amongst international bodies, and there are groups such as the European Commission, the Intergovernmental Panel on Climate Change, United Nations Environment Program, IMO, and the World Meteorological Organization who have been examining particularly CDR and marine CDR. So these discussions have focused primarily on the scientific understanding so far and the pros and cons of different possible approaches. So Environment and Climate Change Canada has a number of mandates that relate to this. The two, I guess, key ones here are taking action on clean growth and climate change. We're the federal lead for a wide variety, so the ECCC is coordinating the government's climate change plan, implementing regulations to reduce emissions, and the greenhouse gas offset credit system. It supports other departments to advance measures supporting Canada's clean growth and climate change objectives, including the CCUS investment tax credit. So that's carbon capture, utilization, and storage. ECCC's science strategy also highlights that the need to improve our understanding of climate-altering technologies in the Canadian context, including marine CDR and SRM techniques, to inform climate change mitigation and adaptation for a net zero resilient Canada. So at the same time, we also have some responsibilities related to marine pollution, and I'll get into some of the legislation and regulations that we have related to this in a little bit. But primarily, we're looking at the disposal at sea regulations under the Canadian Environmental Protection Act and the pollution prevention provisions of the Fisheries Act as well. And ECCC represents Canada at a number of international organizations. The one with which I'm most familiar is the London Protocol, and I'll be speaking a little bit about the work that we do there. So the London Protocol, for those not familiar with it, it is a global UN treaty regarding the prevention of marine pollution, historically from disposal at sea. However, the agreement is evolving over time. And the protocol itself is a modern treaty. It was negotiated in 1996, designed to replace the older London Convention on dumping at sea. So what it does is it basically prohibits all disposal or deposit into the ocean without a permit. And we have a small list of relatively safe and low-risk materials for which we can issue permits. And you see those across the bottom of the screen. But it's evolving beyond the traditional dumping. I mean, the London Convention itself was designed to stop dumping of garbage from barges, but we're really moving beyond that. And in 2006, CO2 streams for sequestration underneath the seabed were added to the London Protocol as one of the items that for which we can issue permits. And we're currently working on the Canadian domestic regulations that are required to allow for that, and in collaboration with NRCan, who have responsibilities related to the offshore and management, such as licensing of the seabed, et cetera. So the London Protocol, so it was amended to add CO2, and this particular amendment was done simply as an addition to the existing dumping provisions. So there was no coming in force provision required, which we'll get into in a second when we talk more about marine CDR and SRM techniques. So in 2007, concern was raised over an ocean fertilization proposal near the Galapagos Islands, and the protocol was fairly quick in releasing a resolution indicating that such techniques are covered by the protocol in that they involve disposal of a material from from a ship, aircraft platform, or other structure. That's kind of the scope of London. And discussions ensued, and in 2013, a framework was developed and adopted that creates a separate framework for what we termed at the time marine geoengineering activities, that trying to encompass both marine CDR and SRM techniques. It was recognized that the existing provisions of London related to dumping at sea did not apply effectively to these, and so a new mechanism was developed. And this is a fairly flexible mechanism in that it was developed and there was a generic guidance created that would cover all of the techniques that could potentially be added to the amendment. I should say that in 2013, the only thing that was added was ocean fertilization, but it was set up in a way that we could add additional techniques as we moved forward. So it's not yet in force. It does require 2/3 ratification in order to come into force. This is fairly slow, and I think it's one of the things that kind of came up at this year's meetings was the difficulty in getting movement on this. Canada is working on ratifying, but we have not yet adopted the domestic legislative changes that are required in order for us to then deposit an instrument of ratification with the protocol. So in October 2024, the parties met, as they do annually. There was originally an expectation that a couple of European countries may present a formal amendment proposal to add additional, up to 4 additional techniques to the regulated list. This did not happen by the deadline, and so the discussions were more towards a resolution or statement. There were some countries that were concerned that we may not have the ability to shift quickly to scaled deployment if we added only research to the schedules or the annexes of the London Protocol, which is how we would add additional techniques. If you take a look at what's there right now, ocean fertilization research is allowed to be permitted, but commercial deployment is not. And I think there are parties that are fearful that if we go the same direction with something like ocean alkalinity enhancement, which is really showing some promise, that we wouldn't be able to pivot quickly enough if we get to the point of scientific understanding to say that this is something that should be deployed on a wide scale. So the tone has shifted a little bit at London, but I don't think that the intention of the parties has changed significantly. There was agreement that we are not yet at a state where we're ready to deploy on a large scale, but we are certainly wanting to put in place a regulatory mechanism that will both protect the oceans but drive innovative research in order to determine whether or not these techniques can be used in order to address the climate change crisis. So we did come away with an agreement. They formed an intersessional group that will look at how to further the ratification of these. Of the agreement and try to get it into force. All right, so current regulatory tools, I've already mentioned a few. We do have the Canadian Environmental Protection Act. In 2016, we did put out a discussion paper looking at the potential amendments to enact the 2013 amendments. We have the general prohibition under the Fisheries Act, and the potential to use regulatory changes to address these issues. ECCC also has a mandate for research, and there are certainly some researchers that are starting to look at this. And I already mentioned NRCan is looking at what it needs to do to allow for CCUS and the subsea bed. So moving forward, what do we need? Interdepartmental work to ensure a cohesive Government of Canada approach on this, research, including government, academic, private sector, and funding for it, working with provinces and territories where research is already underway, Indigenous and stakeholder engagement, and development of options for a regulatory framework. And I will leave it at that. Thanks very much.
Thank you, David. I think your presentation really highlights the complexity of the regulatory and the policy dimension of, on the one hand, protecting the oceans, but on the other, enabling actually research and enabling scaling up and proof of principle type things. So that's fascinating. So Naeem, please, could you give us your thoughts on the expectations from government and the rest?
Absolutely, thank you. Hi everyone, my name is Naeem Merchant. I'm the Executive Director of Carbon Removal Canada. And we're really interested in how government policy can rapidly and responsibly scale up carbon removal technology, and particularly marine carbon removal. Before I get into that, Carbon Removal Canada was ultimately set up to help Canada achieve its climate goals with carbon removal. So we're a philanthropically funded independent nonprofit. We're not an industry association. We thought it was important to set up as an independent nonprofit in order to provide some kind of financial arm's length between the industry and what good policy in this space really looks like. And we're really focused on, we've determined ultimately that Canada needs in the range of at least 100 megatons of carbon removal per year by 2050, and potentially more than that when we think about what's going to be needed well beyond mid-century. And our role is an independent information broker for the government in helping different actors think about what is really needed to scale a portfolio of carbon removal solutions in regards to carbon removal. And we focus on essentially any solution that removes CO2 from the atmosphere and stores it away for centuries or longer. And within that, we are technology agnostic. So we don't focus on point source carbon capture, and we don't focus on nature-based solutions that might have a lower durability than I think what we need, which is in the centuries or longer kind of time frame. And we've identified a number of really exciting opportunities for Canada to lead across the spectrum of carbon removal, whether that is something like direct air capture or ocean carbon dioxide removal or biomass-based methods or carbon mineralization. The entire spectrum, I think Canada is well suited to lead on all of these fronts. So before I get into anything on ocean carbon removal, we think that there's some kind of cross-cutting policies that are necessary in order for Canada to lead in this new space. And the first one we think is to set carbon removal targets, to have separate targets for carbon dioxide removal versus our emissions reduction. And that's helpful because it can set a no-cost signal to the space of here's how much we think we need to do in terms of carbon removal without over-depending on it, which we think is really important. So if we separate those targets out from emissions reductions, then we can have a more focused strategy, a more focused North Star on what it's going to take to scale up the entire portfolio of carbon removal solutions. The second thing we need to do is accelerate innovation. We've mapped 70 plus companies across Canada that are working somewhere along the supply chain of carbon removal. And most of those are happening at lab scale. So we need to develop a fast track innovation program in Canada to help get those projects out of the lab and into demonstration scale so we can learn how they work in terms of their efficacy at removing CO2 from the atmosphere, but also from an ecological safety standpoint. And we're not going to learn a lot of those things if those are projects that are stuck in the lab because they can't get the funding or the permitting to do demonstration scale projects where they're needed. And finally, for projects in carbon removal solutions that are getting more, that are more technologically mature, we see an opportunity to actually create a demand signal in Canada. And we've seen some leadership from the Government of Canada on this so far. Just in this last budget, the Canadian government is committed to buy $10 million of permanent carbon removal credits over the next several years to help stimulate the market and reduce the emissions intensity of our own governmental operations. But what's important to get right is that CO2 is distributed across the atmosphere is a global issue. And so we need to think about the linkages between carbon removal policies and regulations at global levels all the way down to the local level. So there's a number of considerations that we need to take seriously. One of them at the global level is how do we balance the needs under London Convention, London Protocol to protect the marine environment, but to create that innovation space that is really important. That's a really critical consideration that has linkages to how we develop policy at a domestic level in Canada. Nationally, I've already talked about the need to create targets and publish guidance on how we do permitting so that we can ensure that we are developing carbon removal projects that are considering the important environmental impacts that could be experienced in our coastal ecosystems. At a provincial level, we need provinces to be thinking about regulatory frameworks around permitting and getting projects off the ground and the impacts of different carbon removal methods in those localized areas. And then at the local level, it's important to kind of think about and share industry best practices on how local citizens and local communities can engage with these projects as that's the scale at which they'll be operating in. So when we think of what a set of supportive policies for ocean carbon removal needs to look like, I think that ultimately, at a global level, we need to balance the needs for innovation and protecting our marine environments under the London Protocol. That's really, really critical because that has impacts downstream on how we shape domestic policy as relates to ocean carbon removal. At a national level, we really think that there's an important opportunity to establish carbon removal targets in Canada, and that can then flow downstream into accelerating innovation, like I talked about before, and creating that demand signal that we need. But really our North Star needs to be about creating an informed and inclusive public consultation on what scale of carbon removal do we really need to be thinking about and deploying in Canada. At the provincial level, there's a need for regulatory frameworks that help include carbon removal within offset markets. So we've seen some work around this at ECCC and the GHG offsetting protocols that are being developed, but ultimately these are integrated in compliance markets across Canada that operate at the subnational level. And so we need to think about the regulatory frameworks as well as the protocols that integrate carbon removal into those compliance markets to create a long-term market for carbon removal. And then finally, I think there's an opportunity at the local level to just develop industry best practices for community engagement and deployment of new projects. So ultimately, where does this take us? I think we come away from this work excited about the potential for carbon removal in Canada, but we think there's a few key areas that we need to focus on. One is I think we need to really focus on funding innovation. We need to have a standalone carbon removal innovation fund in Canada. Carbon removal is a big part of the climate equation, and so it has a unique set of challenges and circumstances, and so we need to see innovation funding that is specific to carbon removal. The second thing we need to do is essentially mainstream carbon removal. We are seeing right now, for example, Senator Deakin has kind of initiated a study on ocean carbon removal on the Senate floor that I think is really important in helping us understand what's the role of carbon removal as far as our climate plans and climate strategies in Canada. The understanding and getting clarity on those roles are going to be really important as we go forward. We also need to make sure that the research that we're doing is responsive to the needs of policymakers and helping us think about how we align the biggest challenges that policymakers are seeing and thinking about scaling up carbon removal with research questions and research outcomes that are being developed. And finally, I think there's a need to integrate carbon removal within our compliance markets, our climate plans and strategies, and procurement programs like we saw the one that was recently launched by the Government of Canada a few months ago on creating a procurement program for carbon removal services to meet the government's own decarbonization strategy. That's an example of integration of carbon removal. We need to see that elsewhere throughout our political systems. So if you'd like to get in touch or learn more about how we're thinking about the landscape for carbon removal, you can get in touch with us. But happy to answer any questions later on and discuss this important topic with the rest of the panel. Thanks so much.
Thank you very much. So clearly we have here a very intricate connection between policy and innovation, we need to understand what kind of innovation we have, right? To know how we're going to be regulating or enabling. So perhaps we can hear, Mike, from you about the kind of technologies here that we're talking about.
Yeah, great. Well, very happy to walk through it. I'm going to try my best to condense a probably 30-minute presentation into 8 minutes. So everybody ready? Let's go. So my name is Mike Kelland. I'm the CEO and one of the co-founders at Planetary Technologies. Our vision is to protect and restore the ocean and climate for generations to come. Excuse me. Okay, I'm going to start with a very simplified overview of how ocean alkalinity enhancement works to give everybody a sense of what it is that we're trying to accomplish with the research we're doing right now. So first and foremost, it's really important to understand that the ocean and the atmosphere are essentially the same system when it comes to CO2. So Henry's law essentially says that when we get extra CO2 in the atmosphere, some of it's going to dissolve into the ocean, it's going to balance out, we're going to achieve an equilibrium. And the easiest way to think about that is that everything we put in the atmosphere is going to be breathed in by the ocean. And when CO2 goes into the ocean and is breathed in by the ocean, it unbalances that system. So it creates additional acidity within that system. And that acidity has real negative impacts within our ecosystems. So right now we're adding about 27 million tons of CO2 to the atmosphere, to the ocean, per day. So every day, about 27 million tons of extra CO2 is going into our oceans. And BC, for example, has declared that acidification to be one of the top 3 threats to the province and has put in place action plans around it. So this has immediate negative consequences in terms of just that amount of CO2 that's unbalancing the system. Usually, in nature, rocks and the land come together in order to balance that CO2 in the ocean. So rocks are kind of your antacid, your base, and then CO2 is your acid. When there's too much acid in the system, it dissolves more rocks, and it sort of balances it all out. Of course, we've been adding CO2 at a tremendous rate, and that system is a geological system, so it's going to be very, very slow. So what we can actually do is we can create more rapidly dissolving, essentially, antacids, and we do that a lot. There's about 10 gigatons worth of this stuff that is actually just thrown in landfills around the world, 1 gigaton of this stuff that's thrown in landfills around the world every year. When we can purify that and form an antacid that we can put into the ocean, like a Tums essentially for the ocean's indigestion, if you will, we can actually neutralize that CO2 in a local area, help to restore local ecosystems, and also allow the ocean to then have more capacity to take up CO2. So that's how ocean alkalinity enhancement works. And it's already having some really interesting things going on. So as David mentioned, there is an explosion of knowledge in this space right now. There's 10 times as many peer-reviewed papers published this past year than there were, even 5 years ago. So rapidly expanding sort of research and showing some really positive effects on the local ecosystem. So that assumption that if we restore ocean chemistry and deacidify it, we will actually support the local ecosystem is turning out to be very much a true statement. Where a study about a month ago said that if we add alkalinity to species of fish like cod and halibut, we increase the biomass throughout their life cycle. And it kind of makes sense. You've got an ecosystem that's incredibly damaged. We start to restore that, we start to repair that, we're going to have some positive benefits. So Planetary is I would say, the world leader in this space. We have led with our research partners at Dalhousie a lot of the innovation in this space and a lot of responsible research that's happening. What you can see here is our first facility in Halifax, which is a project that we've been working on for a couple years now. And it's really sort of a community effort, bringing together a wide range of different players in order to responsibly advance the research in this field. We announced this week, I think, it's been a long week, that we had the first 138 net tons of removal from our last year's activities accepted by a verifier, which is the first time that's ever been done around the world. So this is a really big deal. So Canada is truly leading in this space. So why does this matter? So let me walk you through some of the science and the background. This is the case study of the research to date. The first thing to keep in mind is that when we talk about carbon removal, the scale that is required is intense. It is absolutely massive if we want to avoid the worst impacts of climate change. And that means one of the biggest things that is going to be a concern for the amount of carbon removal we need is space. So when you look at this system, the blue at the bottom is the largest direct air capture plant in the world. It removes about 4,000 tons a year, I think 3,000 on a net basis in Iceland. And at the same scale on top, you can see the footprint in red of planetary system, which has a nameplate capacity of about 4 or 5 times that. And in fact, if we upgrade the pump, it could be 6 or 7 times that. And so one of the things you see about the ocean-based carbon removal systems is that the scalability of these is much, much higher than a lot of other pathways for carbon removal. In 2023, last year, we did our first sort of major net removal, as I mentioned. This is, what you see here is what's called a dye tracer study. This is how we help to catalog exactly where the carbon removal is happening in the ocean and how things move. Obviously, it was actually accidentally timed with the release of the Barbie movie last year, and so we got a lot of good comments about that. And you can see here one of the things that how it is that we actually do some of this carbon removal. So if you want to grab the QR code, there's a walkthrough video, you can find it on our website as well, of how we actually do the measurement of the carbon removal. MRV is an emerging space here. At this scale, we're very confident in our 138 tons. I can hear the video going already, that's awesome. The way that we do our modeling and our calculation of removals includes both direct measurements across the system, calculations of the total life cycle of the system, as well as ocean modeling, which we partnered with Dalhousie University to do. The other really big aspect of this is that we have to be really cautious in terms of how we scale these systems up. And so we want to be very incremental. We want to be watching for biological negative impacts as well as positive impacts. And so, again, another QR code. You can dig into the science if you want. But we do a lot of work here to make sure that the work that we're doing is very clearly not harming the ecosystem. And so far, again, this is proven to be positive and to have no negative downsides at the scales we're working at so far. And so we look for things like testing the material we use for any impurities, for ecotoxicology, for all of these kinds of things. We look for any accumulation within the environment of any of this material. And we test for impacts on things like phytoplankton and all the way up the sort of the food chain throughout. And so far we're seeing really positive results. Our 2024 project is ongoing currently. The research we're doing right now is ongoing right now. We're using a new feedstock that is providing sort of better reactivity and better dissolution rates, very strong ecotoxicology results across that. We're aiming for about 1,000 tons of net removals over the course of this project, which will probably end early next year. And we are adding a huge amount of additional research as well into the system. So as we've learned and as we've sort of brought together this academic community, we're getting more and more of a view as to what kind of research we can add into this system. And it's really a really cool system because this is the first place in the world that this is truly being done, and it's attracting researchers from around the world to come and study with us in this area. What you see here is like some really cool sort of things from this year. One thing that we did that was thought even as early as last year not to be possible is that we directly measured carbon removal at points within the harbor. And this is sort of how quickly this is going. The general assumption a year ago was it only can be modeled, you can never measure the removal. This year we said, well, no, let's go ahead and measure it. So really interesting stuff going on. From a policy perspective, on the governance side, most of the work we're doing right now is within what we call voluntary carbon markets. And so we're looking for the highest possible standards of both measurement and impact reporting within that voluntary system, because we know that that's how we can scale this in the long term, right? This isn't a short-term thing. It's very much a long-term thing. We want to make absolutely sure that we're setting up for the future. So now there is a ICRO-certified registry protocol that dictates how the carbon can be measured to the highest scientific standards. And our system, because it works within existing outfalls and discharges from land, is easily regulated. And so we've had some really good engagement with David's group at ECCC, with the Nova Scotia Environment Ministries. We are able to have sort of regulators come on site on a weekly basis and pull a bucket of what we're putting into the ocean and test it for regulatory compliance on a weekly basis. There's a lot of very good integration there in terms of how that permitting and regulatory environment fits with what we're doing. So I want to go final little piece, 3 quick things that I'll throw in terms of what I think Canada can do to, yes, very last little quick, so I'll go very fast. 1 minute, okay. So first of all, when we're talking about marine CDR, when we're talking about marine geoengineering, things like that, it's really important to understand that most of the things that fit under those banners have literally nothing to do with each other. So it's very important that we think about the risks, the scale, and the potential of various different MCDR technologies individually in their right context, from a policy context, so that we don't drive towards lowest common denominator when we're thinking about these techniques. It's very important to sort of split them out and understand that they all have very different regulatory frameworks they're going to need and ways of approaching things. The second thing is, it's very important that we drive towards clarity. So Canada and ECCC have been fantastic partners for us in this. There is still sort of this sense that if I'm doing wastewater, I can raise the pH to 9, but when I'm doing MCDR, that might be scary, even though it's exactly the same thing. And so bringing together clarity on what is already permissible and what is the same as what we're already doing is really important. The EPA has actually done this and published that if you're within existing permits, you don't even need to talk to them, you just send them a notification. So that level of clarity is very helpful for the field as we develop in the smaller scales as we grow up. And then finally, markets are absolutely critical. Naeem talked a bit about this, but creating predictability that these techniques will be possible for industries to use to meet our net zero goals is critical to scale and maintain leadership. There you go. That's probably more than a minute. Sorry.
Well, this is great. I certainly enjoyed listening to all of you. I have plenty of questions. We're gonna do 3 questions on topics that were alluded to, not covered, and I really want to leave room for questions from the audience. So the first question, I guess, or that I have, is about governance. And we know that the ocean includes indigenous governance. And I thought, but perhaps, would be interesting to hear how we can ensure this from the policy perspective, and also how we can include, I guess, our indigenous communities in the research and development as well for this important problem. So maybe I'll direct this to you, David and Kate, and please try to answer quickly and complementary.
Yeah, well, I can say, I guess we went out and began an Indigenous engagement process last spring when we were expecting a formal proposal for amendment of the London Protocol. And what we heard overwhelmingly was that, as this is a very new, these are a bunch of very new technologies, and so the understanding of them is not really there yet. So we are currently working on developing an engagement strategy, and one of the first objectives of that will be to get information on these technologies out so that we can have a good conversation. I think there are opportunities for deeper participation in this, and I will give one example that my group has been working on. We have an agreement on joint decision making with the Tsleil-Waututh Nation in Burrard Inlet in the Vancouver area, and there is now a technical review panel that is reviewing all disposal at sea activities, one of our traditional regulatory activities in that area. And it's a very interesting model where the Tsleil-Waututh are not only helping with permitting decisions related to a body of water where they have traditional they have traditional use of, and are trying to develop it so that they can resume traditional harvesting practices in the area. They have gone beyond simply the technical review panel, however, and have started to participate in some of the monitoring of disposal sites that we do in the area. So there's a really good opportunity there for further engagement beyond simply the traditional areas that we've engaged with them on. And certainly an area for them to participate in the research, and there's been a real interest in that.
Kate, I think this is a great segue for you.
Yes, thank you. So I'll just follow up with the work that Ocean Networks Canada has been doing with Indigenous coastal communities, where we've been providing technology and knowledge to actually have these communities actually observe their own oceanfront yard. And we've been doing that now for quite a number of years, started in 2012 in Cambridge Bay. And in fact, just to talk about the Tsleil-Waututh and Burrard Inlet, we have been working with them to have real-time data from an observatory in Burrard Inlet. That now those data are useful. It's their data, the Indigenous communities' data, and that data are really important for essentially looking at a baseline for a potential future ocean alkalinity enhancement experiment that will hopefully come to the West Coast very soon. But already that Indigenous community is part of the baseline knowledge and data. We, as Ocean Networks Canada, we will continue to share our data transparently and work with Indigenous communities to share our knowledge of how these kinds of technologies will be advancing, so that they're aware of them as we actually potentially grow these technologies on all of our coasts.
Great. So we've already started the good work, and we just need to continue and accelerate it, perhaps. Well, I mean, when we talk about, of course, working with the Indigenous communities, we're already starting to talk about the partnership. And I think, you've mentioned about needing a village, actually needing a global village to be doing all this. I'm very happy to see that Canada, we are well equipped to lead, to participate. But I thought that perhaps a little bit more information about, the type of partnerships that Canada should be seeking. Often we're just at the sort of receiving end. How do we proactively engage and with whom? Naeem, do you want to start maybe?
Yeah, it's a great question. And I think, when we think about a gigaton scale problem, it's going to absolutely require international coordination. And I think we should be really proud of the work that's happening in Canada from a research standpoint, from a private sector standpoint, what Mike is driving, and Ocean Networks Canada. We are a global leader, if not the global leader, in ocean carbon removal today. And so what we think about is, how do we maintain that lead? How do we maintain that lead and not give it up? And there's a couple of opportunities that I see where partnerships can be really valuable. When we think about kind of global partnerships and where there's something kind of more immediately actionable, we think about some of the innovation work that's happening, thanks to funding that's available in the United States, as well as some research that's happening off the coast of Iceland and other places. But really, there's not a very large community of globally that are as far along as Canada or could serve as kind of partners in this. But two areas I think are really important for us to kind of leverage our partnerships. One is complementarity of the research that's happening. There's, the U.S. government has had the approach of dedicating research funding to marine carbon removal specifically. And so there's a lot of research that's happening there. There's more to be done. And so when we think about the carbon removal innovation that needs to happen in Canada, how can we make sure that that is additive to global research that is happening, particularly what's happening in the United States? So our research agenda that adds to the field as opposed to kind of duplicating some of the research that's already happening. So that's an obvious one. Another one that I think is going to be really important as we think about what it's going to take to scale carbon removal through voluntary and compliance markets globally. And we think this is really important. The voluntary market is a few $1 billion a year, but the compliance markets around the world, whether that's in Europe or elsewhere, that's an $800 billion market. So how we integrate with those markets is going to be really important. And so from a partnership standpoint, Canada is in the process of developing standards and protocols for different carbon removal methods. we should take a partnerships-based approach to ensure that these standards and protocols that are being developed around ocean carbon removal are harmonized with efforts to do the same as part of the ETS in the European Union and other efforts globally, in Japan in particular, where there's a development of standards around carbon removal methods and the creation of our own standards or protocols that don't synchronize or aren't particularly harmonized with those will just limit our ability to participate in global markets in the long term. So how can we get ahead of that by harmonizing those standards and protocols at the early stage, and using, by the way, the lead that we have in innovation and research and what we're learning and the data that's being collected at Ocean Networks Canada to set a really high bar for those standards, so that we don't have a race to the bottom, but we have these high standards that countries around the world are then trying to match, which I think can have a really big impact.
Well, this is fascinating. Would you say that, like, as you know, Canada now is an associate member for Horizon Europe? Yeah. Will that be, opportunities both on the technology development, the standards, the policy side for collaborations, and have you looked into it?
We have looked into it, and what I'll say, because I know we're kind of short on time, is that we look at the opportunity, the R&D and research and innovation agenda for Horizons Europe, and the fact that Canada can be part of that is a really clear channel for us to be participating in advancing that global innovation agenda around ocean carbon removal.
Yes, certainly.
So thanks for the first aspect that you just touched on in terms of our project on solid carbon. Because of we've been working on this in terms of pre-feasibility and feasibility now for 7 years, that both Japan, as a country keenly interested in advancing this technology as well, is reaching out to us to partner with us and fill gaps that we may need to fill. And at the same time, Germany, and there's a potential with Horizon Europe, is actually going to be participating with their technology in our demonstration project off of Canada. So that complementary international effort, I think, is recognized. And I think we should continue to showcase that we are willing to be that partner to work with others to advance our technology here in Canada.
That's fantastic. So we've talked about these international collaborations, and clearly they're not only with one sector, with academic. It can be with private sector. It can be academic. It can be both. It can be everything. And everyone wants to see more of the private public sector collaborations. We've seen how this got us out of the COVID pandemic in many ways. I look at you, Mike, and I wonder whether you want to maybe give us some thoughts about what are models of successful ones. What's best practice, and particular in this area?
Yeah, so I think it's really important to have, we're not going to solve this large of a problem without partnership across every sector of our economy and what we do. And I'll point to the work that we've got going on right now in Halifax with Dalhousie University as a really shining example of how this can be incredibly productive. So that work is funded by a wide range of philanthropies, as well as government, as well as venture capital, as well as like carbon purchases. There's every source of funds you can imagine that's going into it, and the partnership has proven to be incredibly valuable because we're a startup, and I think within this space we're working in the global commons. Obviously there's a need to engage with the community and to do things in a way that is safe and responsible, while at the same time having the pressures of being a startup, right? And my take on it is that if we form those partnerships in a really good way in this kind of space, the partnership actually allows us all to do the things that we want to do, but better and faster. And so as an example, as I mentioned, we had a huge amount of biological monitoring surrounding our projects, which is appropriate for the scale that we're at right now. We go well beyond our permit in terms of looking for biological impacts across all of the work we do. And that's possible because of that engagement with the academics. And as a startup CEO, you sort of go, well, you're working with academics is going to slow you down, and you don't really want to do that. But what I see it as is almost provides you with railroad tracks, right? And so you can just go that much faster with the confidence that somebody is making sure that your activities are staying within the bounds of safe and effective into the future. Because the other thing about this kind of space, and I think all of the investors in this space know, is that something's going to take a while to reach the point where it's truly going to be a really viable business and all this other stuff. And so if you burn it out today and do something irresponsible today, then you're never going to get your return anyway. So I think that ability to provide that guardrails, which really are an accelerant rather than a decelerant to the private sector in this space at this stage of development, is incredibly valuable. And I think we've proven that with the productive relationships that we've had in Halifax, and soon, hopefully, in Vancouver as well with ONC and UBC, and that's going to be really exciting as we develop that project.
Well, this is great, David. I wonder if you want to add anything on the partnership front. Whether multi-sector, multinational.
Yeah, I guess I would say two things. One is just on the international front. I think we really need to start getting the different. There are a number of different international organizations and treaties that are working in this space, and we need to get them talking together because the goals really are common goals when you take a look at it. From the London perspective, there is the prevention of pollution, but CO2 has now been recognized as a pollutant. So really, it is multifaceted, it is complex, and I think those groups need to work together. Just more on the domestic front, I would say that really we have to move very quickly on this. I know we've looked at what government science there is behind these techniques, and we do have government scientists working in areas related to this, but I think the amount of research that is needed is going to require the public sector, the private sector, and academia to work together to really answer the questions that we need to answer.
This is great. It saddens me though that even at the international level, silos are so powerful. Yeah. Anyways, okay, so we managed to have 11 minutes for questions from the audience. I really hope that there are questions. And am I seeing someone going to the mic?
Looks like I am.
It looks like you are. Please do. And I guess there are mics on both sides of the room. Paul.
Hi, very thought-provoking panel. Thank you for organizing it, whoever did that. My question starts from a presentation I did a number of years back that talked about how people come to beliefs they have, and if you've read Schumer's book on why people believe weird things, you come to the realization that people want to deny carbon or climate change, not because they don't believe it's happening, but they don't like the consequences of it. And one of the consequences of believing in climate change is the need for more regulation. And if I happen to be in the private sector, I see regulation as probably a hindrance on my ability to make more money, right? So if I didn't have to clean up the lakes that I was polluting, I would be wealthier. My question right now, in the age of social media and everything else, what are the approaches we should be doing with respect to policy to get the public really understanding the consequences of inaction? Because you can sort of see, especially in the US, that they're already signaling under the Trump administration, and certainly in the opening session, there was an admittance that he was going to deregulate a bunch of things, and that's actually harmful. I'm wondering about, for example, the rhetoric that's happening in Canada around axe the tax, and I'm not stating any political bias one way or the other. The contrary ad I would run against that is, well, if you want to axe the tax, you may just say burn, baby, burn, or something like that.
Let's
find this amusing, but my question is when you start to think about policy, you start to think about economic impact, and how do you win over the public in that pathway.
Yeah, I think your question is really important, and if I may just like rephrase it, because we're seeing it with a lot of technology developments, right? If the public is not brought along from the beginning, doesn't understand the impact of action versus inaction, that we're going to be working, for nothing, and we can't be also on the defensive versus correcting the disinformation that's out there. So I guess the question that I will have for the panelists, and we can't have all of them answer, so quickly. I saw you were agitated. Okay, you too, Mike. So what is being done? What have you been doing, and what needs to be done by who? To answer this very important question.
Yeah, there's a lot of work to be done in terms of helping folks understand the economic or social impacts of carbon removal, let alone the climate kind of necessity or imperative to do this. And so we've only just started. We're about a year old as an organization. But one of the first things that we did was we tried to model what would the economic impact in terms of jobs and GDP creation, productivity growth be for establishing an at-scale carbon removal sector in Canada. I think it came out to the creation of 89,000 jobs and over 100 billion in GDP by mid-century. And that's great. That's a nice top line number that we could include in our first report, but it doesn't mean very much for folks that are going to be thinking about what does this have an impact in terms of our local reality. So we are going to be spending a lot more time talking about how ocean-based carbon removal, for example, creates economic stability in parts of the country where there's a lot of seasonal adjustment to economic activity, or that carbon removal methods that can be used in agricultural lands create a new revenue stream for farmers, or how certain more technology-based carbon removal methods create new job opportunities for folks that are in the oil and gas sector, or that there are carbon mineralization techniques that can really strengthen new revenue streams for the mining sector in other parts of the country. So we see a lot of economic and social benefits to carbon removal. We haven't talked enough about that. And I think that's one way to get people around, yes, this is going to create some trade-offs for us, but it's not all downside. There's some real economic benefits that I think Canada in particular is uniquely positioned to disproportionately benefit from.
So, okay, but not on the economic side.
Not on the economic side.
Okay.
I'll say one very, very brief thing, which is we have to make sure that we don't stigmatize things before we've had a chance to try them out. And I think that is really, really critical. I have a talking point that David's very familiar with, which is that the term marine geoengineering is the worst thing in the world because you're taking things that have literally nothing to do with each other, you're bundling them together and then talking about the risks of them. And their risks have nothing to do with each other. Just because they all happen in the marine environment doesn't mean that they have anything at all to do with each other. And so by doing that, you're forced to the lowest common denominator, you're forced to stigmatize the entire field. And so that kind of approach can kill it before you start. And I think that's the biggest challenge we have from a communications perspective. Go ahead.
Very quickly, I really want to give the two
we
of
actually have
three.
data
We have three
associated
questions.
we actually conducted research associated with solid carbon with the social scientists that did surveys. And in fact, in British Columbia and the state of Washington, because of the fact that people there have been feeling economically the impacts of climate change, they have a very positive view of that particular project. So I think we need to ensure that we conduct this research in parallel with all of these solutions.
Thank you. Please, can you just introduce yourself, perhaps, those going to the mic?
Yeah, my name is Ashley Mercer. I think actually this is an excellent follow-on question. I want to start before I ask the question by acknowledging that humans unintentionally affect our climate every day. But I sort of wanted to follow on that geoengineering point. How does working in a emerging field with an emerging technology that draws down from the hubris of intentionally engaging in an ecological system really start to challenge how the climate for this technology to move forward is? I came out of a PhD looking out of solar radiation management, working with Dr. David Keith, and I know very well what the sort of extreme end of this looks like. But I think the bleed over comment that you made is really true and that trickle down. And so I'm really interested in understanding how you see that play out and the risks. I think you've articulated, but really start to understand how the hubris kind of infiltrates or sort of remains on the outside. Because I definitely think the science is understanding one thing, but very quickly we start to understand that we're intentionally engaging in a system and instead of unintentionally. Thank you.
Looks like she directed it to you, Mike.
Anyone?
I'll do my best with it, and if I hope I'm getting to the core of your question, but yeah. So unintentional geoengineering experiment, carbon dioxide emissions, for 200 years, which obviously is throwing everything completely out of balance. I think what we have to understand is that, and I think this becomes to a certain extent, a philosophical conversation, which is that humans impact our environment. We always have. And so we've got sort of this question about, we've made a mess. Do we have to clean it up or just stop making it? And I think at this point, it's pretty clear that we've got to clean it up if we want to actually sort of like thrive in the new environment, right? So I kind of think it's a bit of a moot discussion. We do this literally all the time, right? So if you don't talk about climate, you can talk about farming, or you can talk about forestry, or you can talk about fishing. We have an impact on this earth, and it's interesting that we are so scared of cleaning up our mess, whereas we're not really scared of making it, and that's odd to me. So that's my take on it.
Thank you. Please.
Yes, I'm Margot Cordova from University of Ottawa. Thank you very much for a very interesting panel discussion. I wonder if there is not only national strategies, but more like all the continent, because for instance, carbon dioxide reduction and all the problems we are kind of talking now is not a national problem, right? So I wonder if there is some strategies like from North America, even Latin America, because all these problems is kind of a flux of everything, right? So I wonder if even in research, but also in some political strategies.
Kate, David, do you want to take this?
I'm not sure I understand the question.
Well, the question is, like whatever is happening, of course, here in Canada is going to be affecting and I will just add not only North America and South Latin America, but
the way around,
everywhere else. So the question is, are there, I guess, efforts to be tackling things at a regional level to start off with? Have I captured your question?
Yes, like if there is more research going on and decision makers going on, yes.
Go ahead.
Yeah, I'm not sure. I'm not sure in terms of the North American or the North and South American, Central American context, but certainly within some regions like Europe, there are definitely regional attempts to address these, but. Yeah, I think our focus has been more on the international agreements and recognizing that yes, this is a global problem. That what's going on in one country is in fact going to potentially have an effect on another country, and we're certainly aware of the potential for impacts from what we do beyond our borders.
Thank you.
Providing, sharing knowledge for other countries, like for example, in South America, in the Solid Carbon Project, we've identified other parts of the world that could adapt this kind of technology. And now we're in discussions, for example, with research communities in Chile about how this same kind of technology could be adapted in their country because of the similar geologic system and ocean system.
Thank you. Last question.
Oh, thank you. It was interesting presentations. I'm going to bring up no questions particularly about what you said in detail, but just a general comment is that from the point of view of the role of the oceans in reducing the amount of greenhouse gases in the atmosphere, one approach that I was exposed to last week, I happened to be in Taiwan for a week of their committees that I'm on. And one of the things they're doing is actually looking at how they can gain energy out of the oceans in order to not then burn as much fossil fuel. And I went to see the assembly plant where they're putting together great big gadgets with propellers on them that will be put down and floating below the sea level in the water to generate electric energy, which they can then use to offset the need of using fossil fuels, et cetera, to reduce the greenhouse gases overall, because it has a longer, well, let's say an approach. The other point I'd like to make is that, although it had nothing formally to do with this year's session, but I always like to emphasize the importance of realizing the reality is that the climate will change for the next at least 5 decades, even if we were to reduce our emissions to zero tomorrow because of the way it is. And we need to adapt to the realities of a climate change, including what and how does this impact the things we do in the oceans, what the oceans does as a role in terms of, well, production of food, fish, et cetera, and that kind of stuff. It's a different question, but
Well,
we might put it for another session next year.
Yes, thank you very much. Indeed, this was going to be part of my closing, few words. But first of all, I want to thank the panelists. I want to thank the audience for, I think, a very engaging conversation. I certainly come out of this, on the one hand, very proud to see how Canada is leading, that we are, in a position to keep going, but also with the sense that there is so much more that needs to be done, including at the level of the public dialogue. And I think this is going to have to be extremely well managed, because I can tell you, I hear from some corners that they are very scared that we're dumping things in the oceans. Of course, people don't appreciate necessarily all the bad things that we've done voluntarily and involuntarily because they've been captured, etc. So I think all this is going to have to be very carefully communicated and so on. But on the last point, I think also we think of the oceans and different countries and communities and ideologies look at the oceans to help feed the world, to sequester carbon, for navigation, for transportation, for protection of biodiversity. And we're going to have to bring all this together. We can't be doing one good on the one hand that's affecting negatively on the other. So all this to say that multi-sector, multidisciplinarity, everything is going to have to be, really at the center of everything that we do, but fascinating and to be continued. Thank you so much. Thank you.